TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm gonna jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, all of my math friends. Welcome to Wednesday Night Math Live. I'm so excited to be here with you. Thank you, Dr. A, for that amazing introduction. Like he said, we're going to go over about 10 problems tonight, and they do range from kindergarten through 12th grade. So if you are prepping for pre-K through 3, K through 6, GK, Praxis Core, GACE, middle school, high school, we have something for everybody. I do like to start with introductions because it helps me kind of guide our conversation tonight. So the problems are set in stone. I already have a PowerPoint with all the problems. However, I try to pull problems that kind of relate to everybody. And I want to make sure that I'm kind of hitting all the grade levels that are represented here tonight. So in the comments, let me know where you're from, what test you're prepping for, and what college did you graduate from. I'm wearing my UCF Knights shirt because I graduated from UCF with both my bachelor's and my master's. Go Knights. My husband's a USF graduate, so it's a little bit of a split household here, but that's okay. So in the comments, let me know where you're from, what test are you prepping for, and where did you go to college or where are you at college right now? So without further ado, let's go ahead and get started. As I'm working through these problems, please don't hesitate to ask any questions you have. I'm more than happy to answer questions as we're solving these problems. That's why we're here. We're here for you to get the most out of this as you can. So let me know whatever questions you have as I'm solving these. 2 people from Texas, welcome. My husband actually grew up in Plano, Texas. Math 6 through 8 and Math 7, 12. Awesome. University of Alabama. I was an Alabama fan for a little bit. I was like a bandwagon Alabama fan. Tarleton State. That's fantastic. Bachelor's in music education at USF, studying for the GK. Awesome. If you're not part of our GK boot camp, it's incredible. I mean, all of our boot camps are incredible, but our GK one is really good. Texas 4th year. Goodness, we've got so many people from Texas representing the state of Texas. I love it. All right, let's get started. I could sit here and talk to y'all all day long. Hey, Joseph, it's good to see you. Praxis 6 through 12. We have a lot of people prepping for Math 6 through 8 and 7 through 12 tonight. Unfortunately, I wish I had more 6 through 8 and 7 through 12 problems. But I will try to make sure that I'm branching out for all of you. I definitely have problems for you, don't worry. But because most of you are 7 through 12, I wish they were all 7 through 12 problems. Also, there's a bonus problem at the end for my high school people. So I will turn it back over to Dr. A, and then it'll come back to me, and there's going to be a bonus problem. Normally, I turn it over to Dr. A, and we close out for the night. But my high school people stick around for the bonus problem. All right, problem 1. This is totally a GK, Praxis Core, K through 6, pre-K through 3 problem. Gerald works at a local bakery. The bakery can make 342 cookies in 18 minutes. At this rate, how many pizzas can they make in 5 hours? Hey, Teresa. Hey, Hope. It's good to see you. So what we have to do here is the first thing I would do is figure out if I can take minutes and convert it into a fraction of an hour. And in this case, 18 does not easily divide into 60. If we did 18 divided by 60, actually it's 3/10. So it's not that bad. I was trying to make it a lot harder. But I'm going to pretend like it's not an easy fraction. And I'm going to find my unit fraction or my unit rate. My unit rate, I'm going to write that down for us. Unit rate. My unit rate is how many cookies we can make in 1 minute. A unit rate is going to be how much can I do in 1 unit, 1 minute, 1 hour, 1 foot, whatever that is. Hey, Terry, it's good to see you. So our unit rate, if I can figure out my unit rate, then I can convert that into hours and all of that. And this should say cookies. So that said, how do I figure out how many cookies we can make in 1 minute? Well, to figure out that unit rate, I can take 342 and divide it by 18. That's going to give me how many cookies I can cook in 1 minute. So 342 divided by 18. I am going to use my calculator for this because everybody in here except Hope that introduced themselves gets a calculator. GK, Praxis 4 through 8, Praxis 6 through 12. Elementary usually does not get a calculator, but some do. So check your study companion. So 342 divided by 18 equals 19. What does that number represent? You will hear me say that a ton. What does that number represent? That number represents the number of cookies in 1 minute. It is critical, no matter what exam you're taking, that you are processing what each step means. So I did step 1. I figured out how many cookies I can cook in 1 minute. I did this step right here, but then I labeled that work so that I don't get lost in the weeds of a problem that has multiple steps. Then what am I going to do with that information? They asked us at this rate, here's my unit rate, 19 cookies in 1 minute. How many cookies can they make in 5 hours? Well, I have cookies per minute, so I need to figure out how many cookies per hour we can do. And so how many minutes are in an hour? There are 60 minutes in an hour. So if I multiply 19 times 60, that gives me 1,140. That is how many cookies per hour. Then I can take that number, 1,140, and multiply it times 5, 1,140 times 5, and I get 5,700, and that is how many cookies in 5 hours. Labeling your work, or at least keeping a mental note of your work, is super important when you're solving these multi-step problems. Now, as Dr. A said in the introduction, we do have these problems for you in a PDF. So I'm going to copy that link and share in the comments below, so that you can use these problems to study with later if you want. So here is the link. I actually, for those of you who are here a lot, I actually remembered this week to put them in Dropbox. It's shocking, I know. Okay, so there's the link for you to access the problems from this week. All right, let's keep going. Problem number 2. If 4/5 x minus 6 equals 24, then what does 1/2 x minus 9 equal? If 4/5 x minus 6 equals 24, then what does 1/2 x minus 9 equal? All right, let's go ahead and solve this problem. So really, the first thing we need to do is find x, because once we find x, then we can take that information and plug it into what they gave us. So on a K through 6 exam, they might say, if x equals 3, then what does 1/2 x minus 9 equal? They may not make you solve and then substitute. However, on a middle school, high school, GK, Praxis Core, GACE, they will do something like this. So this is more of our K through 6, even pre-K through 3, sometimes you'll see this. And then they can make it more complicated by doing something like this. Now, my high school people, they might give you quadratics, cubic functions, square root functions to manipulate and solve as well. So in this case, we have a linear function, but for my high school people, you can absolutely be given quadratics, cubics, square root functions, all of that. So let's go ahead and solve this. I'm going to solve this for x first, and then I'm going to plug it in. So I have 4/5 x minus 6 equals 24. I'm going to add 6 to both sides. I'm kind of going to do the opposite of order of operations to isolate that x value and get x by itself. So I'm going to add 6 to both sides, and I'm left with 4/5 x equals 30. Now, this is where it tricks people up. How am I going to isolate the x now? Normally, if we had something like this, I'm going to switch colors so we know this has nothing to do with this problem. Normally, if I had something like this, 5x equals 30, we know that the x is being multiplied by 5, so we would divide by 5 to get our answer. But when we divide by fractions, we're really multiplying by the inverse. Because when we divide by fractions, if I did 30 divided by 4/5, we have to do keep, change, flip. So I would keep, change, and flip this. Why does that work? Let me show you. Because if I were to just multiply both sides by the reciprocal, which is the flip of this fraction, I'm multiplying this by 5/4. Why is that significant? Why can I multiply that by 5/4? Because it just gives me a value of 1. If I multiply a fraction by its reciprocal, it just gives me a value of 1. 5 times 4 is 20. 4 times 5 is 20. 20 divided by 20 is 1. That's what we're looking for. Or these 5s cross out, these 4 cross out, and we're left with 1. So I can multiply this side by 5/4, which, hey, that's the same thing as dividing by 4/5 and then doing keep, change, flip. I just cut out a step. So now I have x equals 30 times 5 divided by 4. So x equals 150 divided by 4, and I'm going to use my calculator. 150 divided by 4, x equals 37.5. I'm not done. And in fact, I should have included that as an answer choice here, because a lot of times people will choose that because you're under that testing stress. And so you get an answer, you get an x, and you're like, yeah, I got it. But you're not done with that problem. We then have to take that and plug it into here. So I'm going to take that x and plug it in for the x in 1/2 x minus 9. So I have 1/2 times 37.5 minus 9. 37.5 times 1/2 is 18.75. And 18.75 minus 9 equals 9.75. So our answer is B. All right, as always, if you have any questions while I'm solving these problems, don't hesitate to ask. That's why I'm here. For those of you who are just joining, welcome. We are just solving these problems that I've come up with, and we're just hanging out here on a Wednesday night. Let me know where you're from and what test you're prepping for. This is for my high school people. This is pulled from a 7 through 12. I didn't pull it straight from it. I adjusted it. But it comes from a 7 through 12 like prep stuff, material. Two numbers, P and Q, are shown below. P equals 9 plus 10 to the third times 4 plus 5 times 10 to the second. Q equals 7 plus 6 plus 3 plus 7 times 10 to the fifth plus 1. When P plus Q is calculated, what digit will be in the thousands place of the sum? So this is often a problem that people would get very confused by because it looks very wordy. It looks very official with an R or with a P and with a Q and all of these numbers. But really all this is order of operations to figure out what those values are and then adding them together. That's all it is. So let's explore that. So I'm going to do P up here, and I'm going to do Q down here. So P equals 9 plus 10 to the third times 4 plus 5 times 10 to the second. What does order of operations say? Order of operations says that I'm going to do PEMDAS. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. For those of you who have been here for a while, you recognize that. Why did I bracket underneath, please excuse my dear Aunt Sally? Because oftentimes we get locked into this PEMDAS, but when we get locked into that, we assume that multiplication has to come before division. Addition has to come before subtraction. That's not true. These guys are married. These guys are married. And these guys are married. And so we do them from left to right when we get to that little chunk. So let's take a look at this. Let's explore this a little bit. So 9 plus 10 to the third. I'm going to do my exponent first. However, for those of you who know scientific notation, you recognize that this right here and this right here is scientific notation. So I don't have to do the exponent first if I know how to interpret scientific notation. If I don't know how to interpret scientific notation, I would do 10 to the third, and then I would multiply it by 4, and then I would do 10 to the second, and then I would multiply it by 5. First time on this webinar, is there a more specific window for GK tonight? Hey, how are you? Welcome. No, all 10 problems are usually all 10 problems, maybe 8 of the 10 are geared right at GK because typically our 4th through 8th grade problems tailor to kindergarten through 6th and 7th through 12th. I always try to make sure I have problems for everybody. However, I also will take every single problem that we do and do my best to tailor it for everybody, even if it's not a problem you would see on your exam. So for instance, if we were doing a graphing problem where we were graphing a cubic function, for GK, you wouldn't have to know that, but I would break down the graph, how to plot points, all of that, so that you would at least get something out of that problem. So it's helpful to stick around for the whole hour. Anyways, let's keep going. So scientific notation. Scientific notation says, and this problem right here is perfect for GK. You have to know order of operations. You have to know how to add those kinds of numbers. So this is perfect for you. So 4 times 10 to the third. We know that multiplication is commutative, which means we can reverse multiplication and it means the same thing. That said, if we know how to use scientific notation, we know that I can take the decimal point from here and move it 3 spaces to the right. So 1, 2, 3, this becomes 4,000. Again, you could also do 10 to the third times 4. So I have 9 plus 4,000 plus 5 times 10 to the second is 500 using that same notation. And that's it. So this is going to equal 4,509. There's P. Now let's take a look at what Q is. Welcome, Jennifer. I'm so glad that you're joining us. Taking pre-K through 3 math. Awesome. I will make sure that I address some of the content that's on there. So Q is 7 plus 10 to the 6th times 3 plus 7 times 10 to the 5th plus 1. All right. I'm going to identify where my multiplication is because multiplication is going to come before addition and subtraction. So I have 7 plus 3 to the 6th is going to be 3 million because I'm going to take that decimal and move it 6 places to the right. 1, 2, 3, 4, 5, 6. Now, a misconception is that when I have scientific notation, this number means that's how many zeros I add to my number. That is not true because, for instance, if I had the number 4.2 times 10 to the 5th, I'm not going to add 5 zeros. Here's why. I'm going to move that decimal place 5 spaces to the right. 1, 2, 3, 4, 5. There's only 4 humps for me to put a 0. I only have 4 zeros, but my exponent was a 5. So we have to be careful with that misconception. All right, moving on. 7 times 10 to the 5th, so plus. 7 times 10 to the 5th is 700,000 plus 1. So what is my answer for Q? Q is 3,700,000 8. Now, let's go back to our original problem and see what they asked us. They said, when P plus Q is calculated, all that means is I'm going to add that number and that number together. What digit will be in the thousands place? So we're looking for the sum of these two numbers, and then I'm looking for the digit in the thousands place. So even though this is a GK high school, middle school problem, pre-K through 3, K through 6, you have to know place value. So right there, I've tied that in for everybody. Let's go ahead and add these numbers together. Everybody needs to know how to add multi-digit numbers. So I'm going to add these two numbers together, 4,509, line up my place values. 9 plus 8 is 17. Could I have used my calculator? Yeah, I could have, but I didn't. Now, we're looking for the number in the thousands place. Ones, tens, hundreds, thousands. Our answer is 4, but I'm going to continue on with our exploration of place value. 10,000s, 100,000s, millions, and then that pattern continues. 10 millions, 100 millions, billions, 10 billions, 100 billions, and it keeps going. If I had a decimal, and then I had like 1, 2, 3, 4, 5, when I have a decimal, the place values on the right are tenths, hundredths, thousandths, 10,000ths. Those all have the ths at the end. And that's another very common error is if we happened to have a decimal here, people will mistake thousands and thousandths because they don't read it carefully enough, which absolutely kills me when people say like they think they got a problem wrong because of that, or they take a practice test and they get that problem wrong. You knew that. You just read that word wrong. So make sure you pay attention to the ending of that word to let you know what place value you're looking for. All right. Any questions? Ask, ask, ask. Ryan's race car raced down a 50-meter stretch of track in 22 seconds. The following is closest to the speed of the car in kilometers per hour. This appears like a pretty easy problem, but it can be extremely tricky. Let's go ahead and work through it. So we have a race car going a 50-meter stretch in 22 seconds. What am I going to tell you to do? The same thing I told you to do with the cookie problem. Find the unit rate. That is going to be most beneficial for us when we're trying to convert this into kilometers per hour. So I'm going to find how many meters he goes in 1 second. Am I going to divide 50 divided by 22, or am I going to do 22 divided by 50? I'm going to 0.44. I don't know if y'all caught that, but my watch just picked up on my question and answered it for us. Anyways, I'm going to do 50 over 22. Because when we think about something per something, that division sign is the per. So if I'm trying to figure out meters per second, I'm going to do that division sign in the middle. So meters per second. So if I actually divide that out, 50 divided by 22, I get 2.27272727 repeating. What does that number mean? Going back to that cookie problem, we got to know what each number means in the problem. That is how many meters per second. Now what am I going to do? Because we're trying to figure out kilometers per hour. The next thing I'm going to do is figure out how many meters per hour by figuring out how many seconds are in an hour. So if 1 hour equals 60 minutes and 1 minute equals 60 seconds, if I multiply 60 times 60, then I can find out how many seconds are in an hour. So 1 hour is going to equal 3,600 seconds. Now, if that's how many seconds are in 1 hour, I can multiply it by that value and find out how many meters Ryan is going in 1 hour. So if I multiply 3,600 times 2.27 repeating, that is going to give me how many meters per hour. So 3,600 times 2.27 repeating equals 8,181.8172. It keeps going. That's how many meters Ryan is traveling per hour. But that's not what they asked us. They asked us for kilometers per hour. So I have to do yet another conversion. Conversions are important for everybody. My elementary people, my pre-K people, everybody needs to understand how to do basic conversions. 1 kilometer equals 1,000 meters. I have that memorized. Some tests get a reference sheet where it tells you. Some do not. If you do not, and conversions is something you need to know based on your study companion, I highly, highly, highly encourage you to study the basic ones. So if 1 kilometer equals 1,000 meters, if I divide this by 1,000, I can figure out how many kilometers per hour he's traveling. So if I divide it by 1,000, I get 8.18, which rounds up to 8.2. So many steps involved in that problem. It's important that you keep track of that work that you're doing so that you don't get bogged down in the weeds, because it was such a short little problem. It looked like it was going to be so easy, and yet there was a lot going on with that problem. All right, let's move on to problem 5. All right. Jamie was given 9 toothpicks. If each toothpick represents only one side of a shape, what 2 shapes could Jamie make with the toothpicks? The shapes will share one side, creating a composite figure, and she must use all the toothpicks. All right, let's talk about this. Pre-K through 3 people, K through 6 people, this problem was built just for you. But my middle school and high school people, you gotta know the definitions of everything in this. And then you're gonna have to find perimeter, area, volume if it's a 3D shape of this. So it's important that you understand all of the components that go into that. But let's just focus on our pre-K through 3, K through 6 people for a second. Jamie was given 9 toothpicks. if each toothpick represents only one side of a shape, so we've got 9 toothpicks. 1, 2, 3, 4, 5, 6, 7, 8, 9. And each toothpick represents only one side of a shape. So I'm not doubling up. What 2 shapes could Jamie make with the toothpicks? So I could make a square, 1, 2, 3, 4, and I can make a pentagon. 1, 2, 3, 4, 5. Does that equal 9 toothpicks? 1, 2, 3, 4, 5, 6, 7, 8, 9. It absolutely does. However, let's take a look at what it says. The shapes will share one side. Well, if I take these shapes, I'm going to have to redraw those because those black lines got in my way. So 1, 2, 3, 4, and 1, 2, 3, 4, 5. If I take these shapes and merge them to create this composite shape, how many toothpicks have I used? 1, 2, 3, 4, 5, 6, 7, 8. I've only used 8 toothpicks, even though a square has 4 sides and a pentagon has 5 sides, and that equals 9. So what do I need? I actually need 2 shapes that equal 10 sides because they are sharing a side. So a triangle and a hexagon. Let's count the sides. A triangle has 3 sides. A hexagon has 9 sides. A hexagon has 6 sides. 3 plus 6 is 9. Hey, we have 9 toothpicks, but we're going to run into the same issue. 1, 2, 3. But then if I draw a hexagon from here, 1, 2, 3, 4, 5, 6. I've only used 8 toothpicks. 1, 2, 3, 4, 5, 6, 7, 8 because they're sharing a side. Hexagon and rectangle. Hexagon is 6. Rectangle is 4. That equals 10. That seems like it could be the right answer, but let's keep going. Pentagon and rectangle. Pentagon has 5. Rectangle has 4. That's going to give us the same problem as the triangle and hexagon. Rectangle and trapezoid. That's a 4 plus 4. That's not even close. So B is the correct answer. Make both of them pentagons. That is absolutely a possibility. Could we make them both pentagons? Sure. Let's do that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. So we absolutely could make them both pentagons. That just wasn't one of the answer choices. So that's why it's not an answer. My middle school and high school people, they might ask you to find the area of this. They might say that 1 toothpick equals 2 inches. I don't know how long a toothpick is, but if they said 1 toothpick is 2 inches, what is the perimeter? You would have to be able to solve that. In fact, let's solve that. Let's say that 1 toothpick is 2 inches. We're going to extend this problem. If we had to find the perimeter, do not think that it's 18. I just got really passionate about that. Do not think it's 18. They are sharing a side. And so if they're sharing a side and I'm looking for the perimeter is just the outside. So if I start here, I'm going 2, 4, 6, 8, 10, 12, 14. The perimeter is only 14 because this is not part of the perimeter because we created a composite figure, which means we have 2 shapes that have been merged to create one larger shape. Do I have any problems on the unit circle? Tonight, I do not. However, if you are going to come back next week or the following week, I can promise that I will put a unit circle problem in here. These are all pre-made. So it's funny that you ask that because let me throw that out there to everybody. If there is something that you want to see me work through next week, or the week after, please let me know in the comments and I will absolutely add it in. That's where I get a lot of the problems from, is from you guys saying, I want to see problems on the unit circle. I want to see more pre-K through 3 problems, geometry. I want to see more algebra problems for pre-K through 3. I want to see parabolas for GK, like whatever it is, let me know in the comments and I will absolutely add it to my list of topics that I'm going to cover. All right, problem 6. Sarah is trying to simplify the following expression. The first thing Sarah did was the following. So she's trying to simplify 5x plus 3y plus 2x. The first thing Sarah did was 5x plus 2x equals 3y. What property did Sarah use to complete step 1? So if you don't know the definitions of these properties, you probably should. No matter who you are, you should know the definitions of these properties. Should our students in first grade know the definition of the community property? No. But should they understand how it operates? Absolutely. So Sarah is trying to simplify the following expression. She starts with 5x plus 3y plus 2x. And then she does 5x plus 2x plus 3y. What property did she do? All right, so this, I'm going to jump with the answer, and then I'm going to go back and review each property. This right here is commutative property. Commutative property works for multiplication and addition. It does not work for subtraction or division. Commutative property says, I can add or multiply things in any order. So I can do 5x plus 3y plus 2x, or I can do 5x plus 2x plus 3y. I can do 3 plus 4, and that is going to equal 4 plus 3. I can do 3 times 4, and that equals 4 times 3. That is the commutative property. The associative property. The associative property says, and I always think of the associative property as like my parentheses property. The associative property says that if I have A plus B plus C, I could actually do A plus B plus C. It's similar to the commutative property, but typically the order of things change. The parentheses move spots. So the associative property says that I can change the order of my parentheses, but the order of my objects stays the same. The distributive property says that if I have A times B plus C, I can distribute that A into the B plus C. So I would end up with A times B, and then I would have A times C. So the distributive property allows us to literally distribute. And then additive property, that's not even technically a name of a property. Normally, we would call it the additive identity, not the additive property. So that's not definitely like not even an answer. All right, going back to the comments. Okay, Gary, yes, if this was the overhead view of a fenced area, you would have to add that middle piece. My answer still would not be 18, 9 times 2. It would only be 16 because they're sharing that side. But yes, if it was a fence, you would absolutely have to use that piece. If it was an overhead view of a fenced-in area, but that we weren't dividing the 2 spaces, then we wouldn't need that piece of fence. So all that said, yes, we would have to look at the context of the problem. What time do we come on? Every week we are here at 6 o'clock Eastern Standard Time, and we're here 6 to 7. We do 6 to 12 prep. We do all K through 12 grade levels in the same session. So there will always be problems that are very specific for 6 through 12. There's problems very specific for pre-K through 3, but I try to make sure that most of the problems cater to everybody, and I try to like extend and collapse, scaffold that information for everybody. GK, math, geometry, and standard deviation. You got it. I will add that into my list of things. All right, let's keep going. Problem 7. Okay, this is a really, really, really fun one. I had fun writing this problem. So I have an A and a B because I have 2 different versions of this problem. This one is definitely easier. The next one is a little bit harder. 2 coordinate points of a square include 4, 2 and 8, -2. What is the area of this square? So on a K through 6 exam, they would not ask this problem in this way. But my K through 6 people, you have to know how to graph basic points. You have to know the properties of a square, and you have to know how to find the area of a square. They likely would not ask it in this way, though. Everybody else, you need to know this. So let's look at how to graph these points. Very quick review of how to graph. This is quadrant 1, 2, 3, and 4. If I go up, it's positive. If I go down, it's negative. Makes sense. If I go right, it's positive. If I go left, it's negative. Makes sense on a number line. This is my x-axis, and this is my y-axis. X comes before y in the alphabet. So in a coordinate point, x comes before y as well. So I'm going to do my x and then my y. So if I graph 4, 2, four, 2 would be here-ish. And then if I graphed 8, -2, 1, 2, 3, 4, 5, 6, 7, 8, -2, it would be here-ish. Where would the other 2 points of my square be? It's not going to be up here. It's not going to be down here. It's not going to be over here. If I'm going to create a square, it's going to be here and here. What's the distance between these 2 points? 1, 2, 3, 4. What's the distance between these 2 points? 4. 4 times 4 is 16. Because to find the area of a square, we do length times width. Now, let me give you a more challenging one. 1 coordinate point of a square includes 4, 2. Another point lies on the line y = 8. If the area of the square is 36 units squared, what could another point of the square be? Gary, that's a great question. How do we know that this square was not rotated? So like this. That's a great question. In fact, I should have said, what could the area be? So then if we were to solve that for my high school people, then I would find the distance between here using the distance formula. So I'm going to very quickly do that. D equals the square root of x plus x squared. Oh my goodness, why is the distance formula all of a sudden escaping my brain? I had to like legit Google it. X minus x squared. I knew I was messing that up. Plus y minus y squared. So if I did that, square root of 8 minus 4 squared plus -2 minus 2 squared. So that would be the square root of 4 squared plus -4 squared. So the square root of 16 plus 16, which is the square root of 32. And then I would multiply the square root of 32 times the square root of 32, because that would be, it's a square. So the square root of 32 times the square root of 32 would equal 32. But that is not an answer choice, which tells me that it's not rotated. So that's a great question, and I will absolutely adjust the wording on this so that if I ever use this problem again, it's worded correctly, because that could be an answer choice, absolutely. But because it's not, this square is not rotated. All right, let's go ahead and keep moving. So one coordinate of a square is 4, 2. Another point lies on the line y equals 8. If the area of the square is 36 units squared, what could another point of the square be? Here I worded it correctly because the square could go a lot of different ways. So let's go ahead and graph this. We've got a coordinate point, 4, 2. 1, 2, 3, 4. 1, 2. And then we know another point lies on the line y equals 8. A lot of people will mistake this, and everybody needs to know this. Y equals 8 is not this line. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Y equals 8. We've got two options. We've got this option and this option. A lot of people assume that because the y-axis goes up and down, that this is the line y equals 8. That is the line x equals 8. That kind of makes your brain hurt a little bit if this doesn't make sense to you. Why is that x equals 8? Because I'm going over 8 up something, over 8 down something, over 8 up something, over 8 down something. X is always 8 on that line. So that is not y equals 8. Y equals 8 is this line right here. So if this is my original dot, and I know that the area of my square is 36 units, and I have another point on y equals 8, 1, 2, 3, 4, 5, 6, there's one point of my square, and I know that this side is 6, so let's figure out the other points of my square. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. There's another point and another point. So what are these points? I have 4, 2. I have 10, 2. I have 4, 8. And I have 10, 8. C is the correct answer. Hey, Andrea. Oh my gosh, I'm so glad we're here every Wednesday. So just come every Wednesday and you can be golden. I also am going to turn it over to Dr. A. He's the founder of the company. And if you are still struggling with GK, he has a code. We have boot camps available. And our GK boot camp is amazing. And I'm the teacher of it. So, I mean, naturally, I like it. But feel free to message me on Facebook, Amy Sink, S-I-N-K. I'll type my name. I won't type my name below. Amy Sink, A-M-Y-S-I-N-K. And I can give you more information about that. Could I use a formula for 7B? Could I? Probably. Would I? No, because there's not a formula that's needed. Like, sometimes using a formula is not the best strategy for solving a problem. All right, high school people, this one's for you. But everybody needs to know how to find the area of a square, so this is why I like this kind of problem. To the right is a circle with a circumference that measures 22 pi inches. Inscribed inside the circle is a square. What is the area of the shaded region? So we are finding the area of pieces of my circle. Here's what I would do. I'd find the area of my circle and then subtract the area of my square. So let's go ahead and use what we have. we know that the circumference equals 22 pi. What is the formula for circumference? Circumference equals 2 pi r. So if I plug in my circumference into this, 22 pi equals 2 pi r, the pi's are going to end up dividing out. So I end up with 22 equals 2r. Divide both sides by 2, and I get r equals 11. Why is that important? Because to find the area of my circle, I need my r value. So area equals pi r squared. So the area of my circle equals pi times 11 squared. 11 squared is 121. So the area of my circle equals 121 pi. Now I'm going to figure out the area of my square. How am I going to figure out the length of a side of my square? Well, if the center of my square is here, I know that's 11 because a radius goes from the center of my circle to the edge. I know that's 11 because the radius of a circle goes from the center to the edge. And if this is a square, this is a 90-degree angle. So I'm going to use Pythagorean theorem. A squared plus b squared equals c squared to find the missing side. The missing side is going to be c because it's across from the 90-degree angle. So I have 11 squared plus 11 squared equals c squared. 121 plus 121 equals c squared. 121 plus 101 equals 242 equals c squared. So c equals the square root of 242. I am not going to simplify that unless I have to. So this equals the square root of 242, as does this, as does this, as does this. So how do I find area of a square? Area of a square equals length times width. So I'm going to do the square root of 242 times the square root of 242, which just equals 242. That's why I didn't simplify that unless I had to. Now I take the area of my circle and I subtract the area of my square. So area of my circle is 121 pi. I'm going to multiply 121 by 3.14 as the value of my pi because my answer choices are not in pi form. So 379.94 minus 242 gives us 137.94. Word problems. I will definitely add word problems. That is a 45, 45, 90 because this is a 90-degree angle, so it bisects, absolutely. All right, I'm going to add a slide so that I don't forget what we have asked for. So I've seen someone wants unit circle. Sir William wants unit circle. Word problems. I want to make sure I don't miss anything before I turn it over to Dr. A. GK geometry and GK standard deviation. All right, I'm going to turn it over to Dr. A. If you are studying for the high school, like 7 through 12, 6 through 12 exam, I have a bonus problem for you that we're going to solve. If you are not studying for that, you're more than welcome to hang out with me. I mean, why not? But you don't need to know the problem I'm about to solve. So don't hang out if you're going to get confused by it. But feel free to hang out if you want to just hang out. I'm going to turn it over to Dr. A. He has a special code for you for any of you who want to sign up for a boot camp, and then I'll go over that bonus problem. Functions, I will add that to my list, Kathy. All right, here's Dr. A.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.
Problem. All right. I just always wanted to do that. Normally I have to like cut the stream, but here we are still. Okay. This is for my high school people. If you are hanging out, I'm glad you're here. I wish we could cheers right now, but we can't. So, and I'm drinking water. All right. What is the radius of this circle? This was sent to me. I'm not kidding you. This problem wrecked me. It took me so long to figure this out, and I even had to like enlist the help of my mom and dad. My mom is a high school math teacher, and my dad is a retired systems engineer. We all were working on this problem. So let's get started. It's so fun. Okay. So the first thing we're going to do is think about the relationship of intersecting chords. I'm going to extend this line out and create a chord. A chord is a line that intersects the circle at 2 points that doesn't go through the center. And then I'm going to create a chord that extends down like this. Now, because of the property of symmetry, I actually can do this. So because of the property of symmetry, I know that this is 2. So I know that this is going to be 2 as well. I know this is 6, and I'm going to call this D. And I'm going to call this A. So the intersecting chord theorem says that if I have a circle that looks like this, and this is A, this is B, this is C, and this is D, A times B is going to equal C times D. Got it? Okay. So with that said, I can now take 6 times D equals 2 times this whole thing. Now, again, because of the property of symmetry, I can say that A equals 4. So this whole thing, 4 plus 2 is 6. So 2 times 6 is 12. 6D equals 12. Divide both sides by 6. D equals 2. So that means I'm going to clean this up a little bit. That means that when I extend this out and I extend this down, that whole piece is 6. And this little tiny piece that we identified as D originally is 2. That is critical here in a minute. Now I'm going to create a triangle. I'm going to create a chord that starts down here and ends right here. What did I just do? I just created a chord that goes through the center of the circle. How do I know? Not because it looks like it. We never, ever, 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 ever do things based on the way they look in geometry, especially on these exams. I know that that goes through the center because anytime I have a right angle in a circle where the right angle is on the corner of the circle, the hypotenuse is going to cut through the center of the circle. It's just a rule. There's all sorts of rules we just have to memorize. So because I have a right angle inscribed in a circle, the side that connects the two ends of that angle goes through the center of my circle. So that said, now I can just use Pythagorean theorem to find the length of that. So a squared plus b squared equals c squared. Where did I get the 8? 6 plus 2. 4 squared is 16. 8 squared is 64 equals c squared. 16 plus 64 is 80 equals c squared. But before I finish this problem and before I square root this, I want us to think about something. C squared is the diameter. So if I square root both sides, I get the square root of 80 equals c. I'm going to divide that by 2 to get r. R equals the square root of 80 divided by 2. Now, if I simplify that, I get my answer. The square root of 80, I can factor tree that, 2 and 40, 2 and 20, 2 and 10, 2 and 5. So the square root of 80 equals 4 square roots of 5. And remember, we were dividing that by 2. 4 divided by 2 is 2. So this equals 2 square roots of 5. All right, there's my bonus problem for my high school people that I didn't want to intimidate everybody else with. All right, I will see y'all next week. I will make sure that I include word problems about rate and distance. And everything else we discussed tonight. Thank you guys so much for coming. Andrea, I will look out for that message and I will see you all next week. Bye.